Hello, accelerated chemistry students. This is Ms. Crystal Foley, and this is your Chapter 16, Section 3 video notes all over colligative properties of solutions. So we all know that tea is not the same as pure water. So some of the differences in properties have to do little with the specific identity of the solute. Instead, they depend mere on the presence that there is something in our solution. So a colligative property is a property of solutions that depends upon the number of solute particles, not what the particle is, but the fact that they exist. There are three colligative properties of solutions: vapor pressure lowering, freezing point depression, and boiling point elevation. Let's start off by talking about vapor pressure lowering. Vapor pressure is the pressure exerted by a vapor that is in dynamic equilibrium with its liquid in a closed system. Remember, this means that the liquid is going to the vapor phase, and then the vapor phase is going back into the liquid phase at the same rate. A solution that contains a solute that is non-volatile, that means not easily vaporized, always has a lower vapor pressure than the pure solvent. So if we were to look at these two particle diagrams, the equilibrium is established between the liquid and the vapor in the pure solvent when you have a high vapor pressure. In a solution, solute particles reduce the number of solvent particles able to escape the liquid phase, and so the equilibrium is established at a lower vapor pressure. So ionic solutes that dissociate have greater effects on vapor pressure than does non-dissociating solutes. So 3 moles of sodium chloride dissolved in water produce 6 moles of particles because you will have 3 Na pluses and 3 Cl minuses, so that is 6 particles in solution. If you were to look at calcium chloride, each calcium chloride molecule contains 3 particles as a whole, 1 calcium, 3 chloride ions. So that would be, if you had 3 of them, you would have 9 particles in solution. And then if you were to look at glucose and we're looking to dissolve 3 particles of glucose or 3 moles of glucose, you would have 3 particles. And so that would mean that you would have 3 particles in solution still when it dissolves, because glucose does not separate into ions when it dissolves in water. So the question is, which solution has the lowest vapor pressure? So the vapor pressure lowering caused by 0.1 mole of NaCl in 1,000 grams of water is twice that of 0.1 moles of glucose in the same quantity of water, because you have twice as many moles of particles. If you were to look at calcium chloride would have 3 times the vapor pressure lowering as 1 mole of glucose, because you have 3 times the amount of particles than you do of glucose. Now let's talk about freezing point depression. So when a substance freezes, the particles of the solid take an orderly pattern. The presence of a solute in water disrupts the formation of this pattern. As a result, more kinetic energy must be withdrawn from the solution or removed from the solution to form the pure solvent to go into the solid phase and get into that arranged pattern. So the freezing point of a solution is lower than the freezing point of the pure solvent. The difference in temperature between the freezing point of a solution and the freezing point of the solvent is called the freezing point depression. So freezing point depression is another colligative property. So the magnitude that temperature change will be depends on the number of solute particles dissolved in the solvent, not on their identity. This is why in the winter we throw ice, rock salt, calcium chloride, magnesium chloride, any of the salts, so that's a metal with a halogen. We throw that on our roads and on our sidewalks, because when the sun comes out, or we pre-treat our roads with that material, because when water hits the pavement and it melts, that will mix with our salt and make a solution. So then that new solution will not freeze at normal freezing temperatures, 0 degrees Celsius, 32 degrees Fahrenheit, because the solution has now different properties than water itself. Now let's talk about boiling point elevation. The boiling point of a substance is the temperature at which the vapor pressure of a liquid phase equals the atmospheric pressure. So adding a non-volatile solute to a liquid solvent decreases the vapor pressure of the solvent. Because the decrease in vapor pressure, additional kinetic energy must be added to raise the vapor pressure of the liquid phase of the solution to atmospheric pressure, and then the liquid will be able to, or the solution will be able to boil. The boiling point of a solution is higher than the boiling point of just the pure solvent. So the difference in temperature between the boiling point of the solution and the boiling point of the pure solvent is called boiling point elevation. So boiling point elevation is a colligative property, so it depends on the number of particles and not who they are. And the magnitude of the boiling point elevation is proportional to the number of solute particles dissolved in the solvent. And that is the end of your Chapter 16, Section 3 notes. And as always, all of the information on these Google Slides has been acquired and adapted from Pearson Chemistry's 2012 edition, textbooks, resources, CD, and pearsonchem.com. Thank you so much. Have a good night.